So we're here today in a large field out in the western suburbs of Melbourne, and we're going to have a look at the size of the solar system to scale if the sun was a basketball. Let's have a look. Okay, so we're going to start off with the sun there, the size of the basketball, and we're going to move backwards about 11 meters, and in 11 meters we're going to get to the planet Mercury. Mercury on this scale is about 1 millimeter. Mercury actually is about 36 million miles in reality from the sun. There it is. It's not the nail that I've got in there to stop it blowing away, but that little dot underneath it. Maybe a fraction bigger than a millimeter, but Mercury is about 1 millimeter in size. It's the smallest planet in the solar system, slightly larger than the moon. And there it is, Mercury. We move back another 10 meters or so as we look out to the sun again up there. You can see it in the background. And we go backwards about another 10 meters. And on that scale, we reach Venus. There's Venus, about the same size as Earth. Like I said, not the nail, but the little bit of rock there underneath it. Venus is about 2 millimeters wide, about twice as big, or a little bit more than twice as big as Mercury. It's the hottest planet in the solar system, 470 degrees Celsius.
Well, that's hot.
It's got a very slow rotation. As we look up, we move back about another 8 meters, and we reach the planet Earth. There it is. Now Earth there is on the left. On the very right, we've got the moon, which is very, very small, less than a millimeter in size. Why do we call it the moon, by the way? It's a moon. It should have a name, this is my opinion. But it's like calling a person, or a human being, giving them a name, human or something. But anyway, NASA, if you're listening, change the name of the moon. Give it a name.
That's a great idea.
Yeah. But that is the moon, as you can see there on the right-hand side, and Earth on the left-hand side. Next up, we have the red planet Mars, which is another 15 meters back. Mars is about 1 millimeter in size, according to this scale, if the sun was the size of a basketball. And if Elon Musk has his say, it will be the next planet that we go to. The only suitable planet that we really could go to, in if we're being realistic. So that's Mars. Mars is about 230 million kilometers from our sun. You can see there in the background the sun. And now things start to get interesting and the distances start to get quite vast. So the next planet from Mars is Jupiter. But to get to Jupiter, we have to go even further than all the distances between the other planets combined. To get to Mercury, we had to go 11 meters. To get to Venus, we had to go another 10 on top of that. To get to Earth, we had to go another 8 meters on top of that. To get to Mars, we had to go another 15 meters, with Mars being, on my scale, 44 meters away. But to get to Jupiter, we now have to walk 105 meters to get to the biggest planet in the solar system. I was debating whether to speed this bit up, but I thought it just gives an idea of the vast size of the solar system to walk it. It's even as I was walking it myself, I was aware of the vast distances, but when you're actually out there walking it and you see how much space there is and how little the planets make up in terms of space, it's really quite extraordinary. So there is Jupiter, and I found a rock that I thought looks pretty much like Jupiter with all the gas clouds and everything. And Jupiter is about 3.5 centimeters across on this scale. And as you can see here, we can't really see the basketball. What I was most worried about here was that my basketball would get stolen by a passerby.
If you get it stolen, you won't ever get another one.
So the next planet we go to is Saturn. Now, we had to walk 100 meters to get from Mars to Jupiter. We actually have to walk 126 meters now to get to Saturn. Saturn is 1.4 billion kilometers from the Sun, and is probably the most recognizable planet in the solar system with its ring system. Everybody knows what it looks like.
Oh, it's beautiful.
It's got a very low density that would allow it to float in water, and it has 146 moons, would you believe, with Titan being the largest one of them. So we're coming up on Saturn, which is a little bit further up here. So this is walking geographically north, almost directly north, in a park in a big field out here in the western suburbs. You can see there a look around and you cannot see the sun anymore. It's just too small. And there it is. There's Saturn. Just a little bit smaller than Jupiter. It's about 3 centimeters across. And we are now about 300 meters, a bit less than 300 meters away from the basketball-sized sun. So next up, we are going to Uranus.
That's what she said.
I am the thing from Uranus.
There, I said it. Uranus is 500 meters from the basketball-sized sun, making it about 220 meters from the last planet, Saturn.
It's a long way.
Uranus is 2.87 billion kilometers from the sun, tilted on its side. It appears blue-green in color and is the coldest planet on the solar system. So now we go to the last planet in the solar system, which is Neptune. Neptune, like Uranus or Uranus, however you want to pronounce Uranus. Neptune is about 1 centimeter wide on 1 centimeter in diameter, according to the scale I'm using, where the sun is the size of a basketball. And Neptune is another 300 meters walk past Uranus, meaning we are now at around, when we get there, we're going to be around 800 meters from the basketball, which I dearly hope is still there when I walk back. So Neptune is 4.5 billion kilometers from the sun. It is the farthest planet from the sun. It's known for its deep blue color and supersonic winds. It has winds that reach 2,000 kilometers an hour, and it has 14 moons. Of course, there was a 9th planet originally, which was Pluto, but that has been relegated to dwarf planet status. And you'll realize as you look into the distance, you can see a fence out there in the background. That fence out there in the background, Pluto would be about just past that fence, probably another 30 or 40 meters past that fence, and would be the size of a pinhead. So if you want to know where Pluto would be on this scale, it would be about 30 or 40 meters beyond the fence you can see in the background there. Now, the last thing we're going to look at is the nearest star to our sun. And this is going to be to scale by size, but not by distance. Now that star is Proxima Centauri, which is about 4.2 light years away, or 40 trillion kilometers. It's part of the Alpha Centauri system. It's a very small sun, as you can see. It's about 7 centimeters in diameter. I'm using a plum, a very delicious plum that I bought from Coles. And that is to scale. It is a small sun. That is how big it is compared to our sun, which is a basketball. But what is interesting is, where would it be if it was to scale? Well, as you can see, according to this map from Google Earth, it would be sitting just below Japan, around about where the Mariana Trench is. So if you just imagine floating along the water in a boat and you drop that plum in the water, that is where the nearest star to our star would be located if our sun was the size of a basketball. So I hope you found this video informative. I thought it'd be interesting to have a look at the scale of the solar system and where the nearest star, Proxima Centauri, would be if our sun was the size of a basketball. If you do like this content and found it interesting, please consider subscribing to the channel. And as always, have a great day.